Okay, alright. In this video, we are going to cover physics within some minutes. Okay. Now, first of all, we have to start on the four major types of motion. Right? I call it L, C, H, R. Okay. There is L, C, and H, R. Okay. Now, what does it mean here? The first one is said to be linear motion. The second one is said to be circular motion. The third one is said to be harmonic motion. The last one is said to be random motion. Alright, now these are the four main types of motion. We are going to treat this. We are going to treat circular motion and also harmonic motion and finally random motion. Random motion are mostly in chemistry. Okay, now let's take the first one here: linear or straight line motion. Linear or straight line motion. Okay. Linear or straight line motion. Let's take a note here. Linear motion can be defined as a motion in a straight line. Linear motion can be defined as a motion in a straight line. It can also be called rectilinear motion. It can also be called rectilinear motion. Okay? Now class, let's take some of the questions here on equation of motion. Let's take some of the questions here on equation of motion. But before we take equation of motion here, let's list out all the equation of motion for linear. The first equation of motion here is V is equal to U plus AT, please take note. The second one here is V squared is equal to U squared plus what? 2AS. Okay? The third one here is X is equal to 2T plus what? Half AT squared. The last one here is X is equal to V plus U over 2 all times T. Okay, we only use the equation of motion whenever the parameters are said to be 3 or more. Please take note. Whenever you are doing any equation in terms of motion and the parameters are said to be 3 or more, at that point you use what? Equation of motion. Let's solve one example. Okay, now let's take example 1 here. Let's say example 1 here. Okay, a car traveling at 36 km per hour accelerates uniformly at 2 meters per second squared. Full stop here. Calculate its velocity in meters per second in 5 seconds. Okay. When you look into this particular question here, this is straight line motion, right? Because a car can never travel in a vertical way. Car will travel what? In a straight line, right? So since this is a straight line motion here, I will use equation of straight line motion to solve this. Now, if you look here, listen, we have formulas relating to motion and we have equation of motion. We use equation of motion whenever 3 or more parameters are given to us in motion. But if I have this to be, maybe distance is given to me in meter and time is given to me in 5 seconds. And I'm asked to find velocity here. What I will use here is formulas relating to motion. What is the formula here? If I'm asked to find velocity here, I will use the formula for velocity, which is to be velocity is what? Distance or displacement about what? Time, right? I can now solve for what? Velocity here. But since these parameters here is said to be more than 3 here, at this point I'm not going to use this formula here. I will use what? Equation of motion. So let's list out the parameters, obey the conditions, and solve the problem here. Let's list out the parameters here. Okay? Given parameters What is given to us there? The first one is that a car traveling at, that the car is starting the journey at this stage. And the velocity that the car starts the journey with, we call that velocity as initial velocity, right? This statement of this, okay? Now, what again they say, accelerate uniformly at 2 meters per second. Okay? Now, but before we solve this question here, there are some certain words you might hear in terms of motion. What are the words here? Just remember this, that whenever an object starts from rest, that u is what? 0, this statement. Whenever an object comes to rest or is brought to rest, v is what? 0, this statement. Now finally, the last word you can hear, maybe, whenever an object moves in a uniform velocity, a is what? 0, this statement. Okay? Now let's list out the parameters here. The first velocity there is said to be u, that is our u there is said to be 36 kg per watt hour. So converting this to meter per second is going to be 36 times, what is kilo here? We have prefixes in mathematics. We have kilo as 1000, we have milli, we have what? Micro, please take it. When we say about kilo, kilo is said to be 10 raised to 3. Milli is said to be 10 raised to minus 3. Please take note. Micro is said to be, we use this sign here to represent this as what? 10 raised to what? Minus 6. Pico is said to be, please take note, 10 raised to what? Minus 12. We have femto and up, okay? We have aston also, depending. Okay? Now, whenever they mention kilo there, just know that you replace that letter as what? 10 raised to 3 or 1 as this thing. You just like the prefixes. But I have this to be 2s like this, and they say s is equal to 1. What do you do? Anywhere I see s, replace s as 1. So the same thing as this here. So whenever I see kilo here, replace kilo as this number. Whenever I see this, replace milli as this number. The same thing as this. So this is going to be 1000 here. I will left with meter here over. Now, what is the relationship between? Because I want to convert this here from kilometer per hour to what? Meter per second. What's the relationship here between 1 hour and seconds? So that 1 hour is the same thing as what? 3600. So this is the same thing as what? 3600. Now this time we cancel this down here. This we cancel this. This we cancel this. That means our u here class will be equal to 10 meter per watt seconds. Okay. Now that is the first parameter here. We have converted this here to our SI, that is meter per second here. And I say accelerate uniformly here. What is the next parameter here? It's said to be A. It's said to be 2 meter per second squared. Okay. Now they say calculate its velocity in meter per second in 5 seconds. So we are asked to find V, please take note of this, at t equal to 5 seconds. Okay, we are asked to find V at t equal to 5 seconds. Alright, let's solve the question here. But this one you should understand in terms of the equation of motion here. You check the parameters given to you. You know the one you are asked to calculate. And at that point, if that particular equation is valid, you can use that equation. Let's check this one here. Let's check this one here. Class, we are asked to find V. Okay, V is here. U is given to us already. Acceleration is given to us and t is given to us. That means this is valid here. Now, why am I not going to use this one here? There is no distance given to us there, right? The same thing here. There is no distance given to us there. Okay, let's take the same thing here. There is no distance given to us here. Like this is invalid. This is invalid. This is invalid. This is for valid. You cannot use for this. So we say using equation 1, that is V is equal to U plus what? 8. So what is our U here plus? U is equal to what? 10 plus. What is our 8 is 2 times. What is our T is 5. So this will be equal to 10 plus 10. What is the answer? 20 meter per second. Alright? So this is how we solve the equation of motion of any kind. Okay. Now let's move to the next motion here, that is circular motion. Alright, and I told you guys that we have 4 main types of motion, which I told you guys that is going to be L, C, and H, R. Now we have treated this line, that is linear or straight line motion. Now let's treat this line here, that is circular motion. Okay, now let's know what the circular motion is. Now say circular motion can be defined as a motion in a circular path. Circular motion can be defined as a motion in a circular path. That is this here. This is the path I'm saying. Circular motion can be defined as a motion in a circular path. Okay? Now, let's consider the formulas relating to circular motion. The first formula here we see that is said to be linear speed or linear velocity. We say to be V is equal to omega r. Please take note of this. The next one here we see that is said to be, if I call this linear, please take note. You call this linear speed or velocity, or you call this tangential speed or velocity. The next one here is said to be acceleration. That is, we call it tangential acceleration, which is said to be A is equal to plus. I will have this to be alpha of r here. We call this tangential acceleration. Okay, when it comes to acceleration here, it's not the same formula with linear. What is the formula for linear acceleration? The formula for linear acceleration is to be A equal to omega square r. This is what we call linear acceleration. Okay, the next one here for formula relating to circular motion is what? Centripetal force. The formula is said to be this, that is mv squared over what? R. Please take note. Now lastly, 5 said to be centripetal acceleration. And we call this AC as what? V squared over what? R. Okay? Now we have derived this in our previous video. You can just watch on the video on how to derive this. So our intention here is to apply them. If I'm giving omega, that is the angular velocity, I'm giving radius here. Maybe I'm asked to calculate linear speed or tangential speed. I'll just write down the formula and calculate, right? Now the same thing here, if I'm giving alpha here, I'm giving radius here, and I'm asked to calculate tangential acceleration, I will just do this formula that the same thing as this, the same thing as this, and the same as this, right? Alright? Now, let's solve the question here. Let's number 1, please. Alright, now let's solve this question here. But just know that this equation is said to be formulas relating to circular motion. Please take note. Alright? Now let's solve this question here. Let's see how we can use this equation. Let's see how we can use this formula here to apply on this question here. They say a body on a circular orbit makes an angular displacement given by theta of t, that is function of this displacement, angular displacement, a function of time, is equal to 2t squared plus 5t plus 5. If time t is in seconds, calculate the angular velocity at t equal to 2 seconds. They gave us option here, so let's try to solve the equation to see if there is any option here. Please take it. Alright? Now, this is what you should understand here. This should not confuse us here. It's just that the output formula later here will be what t. Now what we see there is a function. Please take it. Just like if I have this to be f of s like this, it means that the output here will be of later of s. Please take it. So the same thing here, since I have this to be t here, the output later will be what? T. Please take it. So now let's try to understand this. Whenever we have distance, please understand this concept. Whenever we have distance, and maybe the distance is written in terms of later. Okay? Now, and you are asked to find maybe velocity
or you are asked to find acceleration, at that point you use what we call instantaneous motion. Now this is angular displacement or angular distance. This angular distance, or it can also be angular distance, depending on what is called in the equation. So this is angular displacement here, and it's given to us in terms of meter here. Please take note. So whenever it is given to us in terms of meter, we use what? Instantaneous motion. So what does it mean in terms of instantaneous motion here? Let me explain clearly on what we mean by instantaneous motion. Okay, now let's know more about instantaneous motion here. If I have this to be x to be equal to 2t raised to the power of 3 here, and you are asked to find velocity here, you use instantaneous motion. Please take note. Now, how do we apply instantaneous motion here, class? If I'm asked to find velocity here, this is going to be the formula for instantaneous velocity to be v is said to be dx over what? dt. That is change in displacement over what? Change in time. So you can just replace this distance d over dt of x. Please take note. And our s is what? 2t raised to the power of 3. So this will be the same as d over dt of what? 2t raised to the power of 3. So what does it mean here? It means differentiate this guy here with respect to what? Time. Please take it. And how do we differentiate here? If I have this to be y to be equal to as raised to the power of n here, this is what we call differentiation by what? Monomial function. It has one digit later at the power here. That means to differentiate this will be dy over what? ds is equal to, take the power here down to the base, right? This will be n times of a, subtract 1 from the, what's the answer? S of what? N minus 1. Do you get that? Now, if it's more than one monomial here, we differentiate this one after the other, whenever it is polynomial. So let's try to differentiate this. The answer to this will be equal to 6t squared. I hope you get that. And if the t is given to us here, we can just replace our t to have what? Velocity. So in terms of acceleration, our instantaneous acceleration is said to be dv over what? dt. Now if our v is given to us here, we can just replace our v and do what? Differentiate that. But if displacement is given to us, and we are asked to find acceleration, it means I have to get velocity first before I get what? Acceleration. I hope you get this. So if you look into this question very carefully here, we are given displacement and we are asked to find angular velocity. Apply the same thing we always do in terms of linear in relating to circular. I'm going to have this guy, please take note. I'm going to have this guy as omega will be equal to d theta over what? dt. I hope you get that. And theta is, this will be equal to class d over t into 2t squared plus what? 5t plus what? 5. Now what does this mean to us? It means differentiate this thing here, right? And we are going to differentiate this one after the other, just the same way we apply this. So our omega here will be equal to class differentiate here. What is the answer of this class? 4t. Class, are you guys okay with this? Now there's an invisible one here. Remember, this is polynomial here. We differentiate this one after the other here. Take the power here down to the base, it will be what? 5. Subtract 1 from what's the answer? 0. So this will be what? Plus what? 5. Because t raised to 0, what is the answer? 1. Listen, anything raised to 0 is what? Plus 1. Now this is a constant because there is no attachment of letter to it. So differentiate a constant, we say, when you differentiate a constant, the answer is always what is that? 0. So the differential coefficient of a constant is that 0. So our answer here is said to be in rad per second. So, but if you look into the condition here, they gave us the time, that is t. What's our t? This is 2. So we present our t as 2 here. Our omega here, please take note, is going to be okay, representing our t here, our omega is going to be 4 into 2, right, plus 5. So let's calculate. This will give us what? 8. That is 8 plus 5. What is 8 plus 5 this class? That is 13, right? So give us 13 rad per second. That is okay. Alright, okay, let's solve question 2 here. They say if the radius of the circular orbit in question 1, that is the previous question we solved, is 50 cm, calculate the linear velocity of the body. Okay, this is very simple here. We all know the formula for linear velocity with the formula relating to circular motion. So we say that the formula is said to be V is equal to omega r. Alright? Now our omega is already 13 rad per second, and they gave us radius to be equal to class to be equal to 50 cm. So convert this to meter. What is the answer? 0.5 meters. Alright? Now that means our V here will be equal to class. Omega is what? 13 times R is what? 0.5. Okay, let's point to our calculator. 13 times 0.5. Let's get the answer here. Look over here, without getting question 1, you can't get question 2. That's why you have to be very careful in question 1 before you solve question 2. Okay, 13 times 0.4, what is the answer to this? That is 6.5 in what? Meter per second. Okay? Alright, let's solve the next question here. Okay? Calculate the rotational kinetic energy of an object rotating with angular velocity of 20 rad per second if the moment of inertia is 12 kg meters squared. They gave us option there. We don't know if it is correct. Okay? Let's just solve it and confirm. But this question introduced mostly on rotational motion. Now, rotational motion and circular motion is kind of the same. The only difference is that the circular motion, the motion is moving a circle without a fixed point, while a rotational motion is moving a circle with a fixed point. Please take note. Okay? Now let's try to know more about rotational motion here. That is the analogy between rotational motion and what? Linear motion. Now, what are the analogy here? That's the relationship here. Now, the first one here is linear motion. The second is what? Circular or rotational motion. Please take note. Okay. Now, the first thing here is distance. Is seen to be S or X. So in terms of circular or rotation, don't call it distance, call it angular distance or displacement. Use what? Theta to represent distance here. Now the next thing here is acceleration. Acceleration is said to be A or small letter A. Here we call it angular acceleration. Please take note. Is said to be alpha. The next thing here is said to be mass. We use n to represent this guy. Now we call this what? Moment of inertia. We use what? I to represent this guy. The next thing here is force. And we use tau to represent this. What is this thing here? Let's relate this to understand the formula here. Mass is I in this. Acceleration is what? Alpha in this. So we have formed this. So from this fundamental parameter here, you can form any formula at all in terms of circular and linear. Okay, now let's try the next one. Kinetic energy here is said to be half mv squared. So this will be 1/2. What is our mass here? I. What again? Omega squared. Remember our V. Okay, we are not putting this. We use the omega as what? Angular velocity. Okay, let's consider this one here. Okay, now let's consider this one. In terms of angular velocity here, it's said to be we say velocity. We use V or U, but we call this angular velocity. We use what? Omega or omega naught. Please pay much attention here. Okay. Now from here you can form any parameter at all. Okay, now let's play around with this analogy, with this relationship between linear and circular or rotational. Let's play around with this. Now, if you are asked to maybe form the formula for power, how can you form the formula for power here from the analogy here? Now, first of all, relate the one you know, that is for linear. Linear is said to be for work done over what time, right? And this can also represent F of V. Am I correct? Now let's go back to this guy here. Now in terms of power here for rotational or circular, so that work done here, remember work done here is force times distance, right? That is what is force? Tau. Distance is theta over what? T. Now the only thing that meaning dot here in physics that has a physical meaning here in physics is what? Change that displacement over what time? What is this? Omega. So this goes before to tau of what? Omega. This thing, and this look the same thing here. Tau take place of force, while omega take place of what? Velocity. So this is how we can easily form this in case. Okay. Now let's solve our question here. What and what is given to us here? Moment of inertia is given to us, and what again? Our angular velocity is given to us. So let's choose our formula here. For kinetic energy here, the formula will what? Half I omega squared. Alright? Okay, let's solve this. Alright, and let's play around with this. They say a rocket engine delivers 320 Newton meter of torque at 100 rev per minute. Of course, rev per minute is not the main SI unit. You know you have to change it, right? Okay, find the power output of the engine. Okay, now if you look right here, it's said to be a rotational motion. So at that point, we are given torque, we are given the angular velocity, right? So let's see if we can calculate the power here. We say that power here is said to be, let's take note of this, that is work done over time. Okay, that is for linear. We want to use linear to justify the rotational part, and this is not formula relating velocity here because there is velocity there. So this is the same as what? Force times displacement over what time. This is distance in the given direction. So we call it what? Displacement. So displacement over time, what will be the answer? Power will be equal to force times what? Velocity. Please take note of this. So now let's relate this to rotational. So this is the same thing as power will be equal to work done over this. Our work done here will be torque times what? Theta. That means our angular displacement is what? Theta over what? Time. So the only thing that will have a physical meaning here in this is what? Displacement over what? Time. This is what? Angular velocity, right? So our P here will equal to tau of what? Omega. So our tau is given to us as, that is our torque, is given to us as 320 Newton meters. Now our omega is given to us as 100 rev per minute. Now let's convert this guy here from rev per minute to what? Rad per second. So this is going to be equal to 100 times 2 pi rad over what? 60 in seconds. So totally here, our omega here will be equal to class. On your calculator, this will cancel this first. Okay, now we have 20 times 3.142. Just on your calculator, 20 times 3.142 dt in seconds. So totally here, our omega here will be equal to class. On your calculator, this will cancel this first. Okay, now we have 20 times 3.142. Just on your calculator, 20 times 3.142 divide by 6. Alright, what's my answer there, please? Okay, what's my answer there, please? That is 20 times this 10 times 2 give us 20 times 3.142 versus what's the answer? 10.473 in rad per what? Seconds. Alright? Now we have fully converted this down here to be in rad per seconds here. So we can easily calculate our power here. That is the power output. So let's calculate the power output. No. Okay, let's calculate the power output here. So this will be P will be equal to plus. Our torque here is said to be 320 times. Our omega is said to be 10 point what? 473. Point your calculator. What is the last answer here? 320 times 10.473. What is the last answer here, please? Okay, 320 times 10.473. 335, yes. 0.111, that is.
No, 335, 1 point.
So 335, 1.36, like this, in watts. Okay, let's see if there's anyone that looks like that. Okay, now approximate this, that is changing that in kilo. Kilo means 1,400, that is divided by 1,000 to change to kilo. So our P here, we want to divide this by 1,000 here. This will be 1, 2, 3, right? This will be 1. The point is here, right? This will be 1, 2, 3. This will be 3.3 of 5. Please take note of 1 kilowatt. So this is our answer here in kilowatt. So there's no option here. This is not the option here. Please take note. Alright? Okay, and let's solve this question here. A body undergoes SHM. SHM is said to be simple harmonic motion. We are going to know what simple harmonic motion is. According to the equation, F is equal to 6 cos 3 pi t plus pi over 3. Okay, close bracket. What is its amplitude, frequency, and period? What is its amplitude, frequency, and period? Okay, now class, let's solve this question here. Before we solve this question here, I have to introduce more on SHM, that is harmonic motion. Now, what is harmonic motion? You can either call it harmonic motion or what? Periodic motion. Now, what is harmonic motion here? It is also known as periodic motion. Now, a periodic motion is a motion that will be set in a given interval or in an equal interval. Please take it. Okay? Now, sometimes, whenever you are given an equation of simple harmonic motion, what is the equation of simple harmonic motion here? The equation is said to be either x or y. Now, this can be x and be y. Anything can be here, basically, any data can be here. Is equal to a sine omega t plus or minus 5, okay? Or is the same as x is equal to a cos into omega t plus or minus 5, okay? Now, this is what we call equation of simple harmonic motion. Please take note. So, how do we solve this? First of all, before we solve this here, let's try to know their parameters one after the other. S is equal to displacement, A is amplitude, this is angular frequency, this is time here, this is phase angle. Plus or minus means that this is plus, means that the wave is moving from right to left. It is minus, it means that the wave is moving from left to right. Please take note. So the same thing here, the same thing here, okay? Now, if the equation is given to us in terms of cost, we do this course here, we compare what is given to us, and before we calculate what we are asked to calculate. This is the method we solve simple harmonic motion equation here. Now, since this is given to us as S is equal to 6 cos 3 pi t plus pi over 3 here, this is the given equation of motion, right? Now, the given one here is what? This class X is equal to 6 cos into 3 pi t plus what? Pi over 3. We compare this one here, this is the given one, to the standard one that looks like this. The standard one are either this or this. Now the one that is of course here is what? This one here. So compare this with the X is equal to A cos into omega t. Since this is plus, I will use plus. But if it is minus, I will use what? Minus. This will be plus of what? 5. Okay? Now, this is my what? Equation 2. Let's compare. Comparing equation 1 and equation 2. This is displacement, this is displacement. This is amplitude here. So anything on this position here will amplitude. This thing. So our A here is said to be 6. But if you look into this equation here, there is no unit title to this guy here. So it means that whenever the unit is not specified here, we always use the SI unit. That is what? Meter for distance and time for what? Seconds. Omega as what? Rad per second square. But if I have this to be in cm like this, means that the cm is affecting everything outside, not everything inside. What are the two of outside here is this guy and this guy here. So that is only what the cm will affect. So unless it's being specified that this is not in SI unit, alright? Now, but there's nothing here. Since there's nothing here in class, it means that everything here is what? In SI unit. So it means that our amplitude here is what? 6, and amplitude is what? Our maximum displacement. What's the unit of displacement is what? Meter. We have compared this to this. Now there's nothing like cos in terms of parameters relating to circular motion. Sorry, parameters relating to harmonic motion. So we can't compare this and compare this. Let's go back to this. Compare this and compare this. We are going to have omega t is equal to 3 pi t. There is t at the left, there is t at the right here. So I can now divide both sides by t. So our omega will be equal to 3 pi of rad per what second. You can replace your pi to the 3.142. Please take it. Okay, let's compare again. This position here is phase angle, or you can call it phase difference. So this position here should be phase angle here. So phi is equal to pi over what? 3. What's the unit? Rad. Please take note. Okay? Now this is what you should, whenever I see something like this is what you should do first before you calculate what you are asked to calculate. So the first one here, amplitude A is said to be 6 meter. The second one here is frequency. And how can we get frequency if angular frequency is given? Now the relationship between what? And please take note. Is it? 3 divided by 2 is 1.333, right? Okay, now 3 divided by 2 here is said to be 1.5 hands. Okay, now we are plotting our frequency class. So that period here will be very simple here because period is said to be inverse of what? Frequency. So our period here, class, our period here is going to be class that is t is equal to 1 over what? F. So replacing this as 1 over 1.5. So what is our answer here? T will be equal to class 1 divided by 1.5. What is the answer, please? Just point your calculator. The answer is going to be 0.67 seconds. Please take it. Okay, now 3 divided by 1, sorry, 1 divided by 1.5 will give us what? 0.67 seconds. Alright, okay. Now just subscribe to the channel to get part 2 of how to cover physics within some minutes.
Miracle, no they tire Jesus, so to bless the person, no they tire Jesus, so he don't